Hello, my name is Derek from Tomcat Gas Training, and the video you're about to undertake is all about this. Now this is an iGEM GM PRS 29N6 meter regulator. That's what it is. And the video we're about to undertake is all about tightness testing of this regulator and this E6 meter. The documents we could be using to help us with this are these, which is the iGEM UP1B edition 3, okay, and that came out in 2012. And we're going to be also using this one, which is the BS 6400 Part 2 2018 specifications for the installation, exchange, relocation and maintenance and removal of meters not exceeding 6 meters cubed an hour, and that is the 2018 edition. So they're the nominative documents we could be using to help us do this. This isn't a video I was ever looking forward to doing, because the actual manuals, the training manuals for tightness testing for this regulator are a bit vague. And in the British standards, the 6400, it says one of the ways of testing this. So I'm going to be kind of going through the way I personally do it on site and incorporating pretty much what the regulations actually say. But what I want you to do is, once you've watched this video, I want you to comment down below and tell me how you do it and which way you find the best way of tightness testing medium pressure. So, waffled enough now. Without further ado, let's get on with it. Let's have a closer look at this regulator. Basically, what we've got coming in here is our inlet gas supply. Now, unlike a low pressure system, the pressure here is between 75 millibars and 2 bar. That's your medium pressure. Your low pressure tightness testing is up to 75 millibars. So that's the first difference, is the anaconda. The anaconda is a lot smaller, okay, because of this pressure, and we'll talk about that in a bit because it's caused a few problems. Now the next thing we're coming up to is this vent. And this vent is basically, every time the regulator works, it will put a little bit of gas out, and this will vent it outside the box. Now this must terminate outside the meter box, and it must protrude more than 25 mil, but no more than 75 mil. And there's also a test we need to do on this to see whether the actual regulator's passing through the safety device, but I'll show again that later. This is the regulator itself, and what we've got here is this green handle here is what's called the reset lever. Now this has an under pressure reset lever. So if there's anything happens and it goes under pressure, then it will lock out. Now there's also an overpressure regulator in here as well, and this is what the vent does. If it goes over regulator, it vents out through the box. But we can't reset this. Okay, if this was LPG, we would be able to reset this, but this is natural gas, so we can't. So the overpressure is in there, but we can't reset it. The under pressure lever, we'll be using that quite a lot. Okay, then the next thing we come to is this. Now, this causes quite a few problems in training because this is called the MIV, or the meter inlet valve. Okay, it used to be called the customer control valve. Now, I'm guessing now years ago, it's over 10 years ago, when these started to become popular, they're not very popular now, but anyway, when they came out with a lever, with a handle on there. And what was happening is, if we were getting any leaks, the customer was closing that lever off, but it was leaking on the anaconda. So it was still leaking gas, instead of turning off the ECV. So we had to go around, if we ever came across these, and take the handle off. But the regulations say if it's missing this valve, then we should be reporting it to our ESP. So it's a contradiction, and this is one of the reasons why we've got 2 tests for this. We've got one test with the valve missing, and we've got one test with the valve in position. But this is classed as it missing because the handle's missing. And this is how you buy them. So this is how I bought this regulator with the handle missing and no way of putting a handle on it. You could get a spanner on there. So there's two tests and we're going to look at the two tests. You know, already we've got, you know, contradictions. And in the training manuals, it says you can do this test, you can do a tightness test, if this valve is missing, but you must inform the responsible person that it's missing. Anyway, it is what it is. But so there's two ways of testing it. We're going to look at the two ways. So that's a close look at the regulator itself and its components. If any of these fail, they have to be replaced and you must contact the emergency service provider, because at the end of the day, it's the responsibility of the supplier and the transporter, not us. So that's a look at the bloody thing. Let's have a look at doing the tests finally. Now, first test, as always with any gas meter, will always be visual inspection. Now, this is a lot different than the low pressure system. The first thing on your visual inspection, if you find one of these meters inside a property, it's at risk. These cannot go inside a property because of the vent pipe. So that makes them at risk. If your vent pipe, anything wrong with your vent pipe, it's not in the right location, it's at risk. If it's too close to vents, windows, because you've got to be careful whether it's too close to vents and doors and electrical components and stuff like that, then it's, you know, it's at risk. The other thing as well is the gas pipe itself has to come out of the bottom of the meter box. It can't go through the back of the meter box. And I've got some labels here which I've blown up so you can read them, but we'll talk about those in a little bit. These labels also are required, but the first thing we'll talk about is earth bonding. Now, in August, the ACS is going to change about safe isolation. And we've always, I think since 2015, they've always wanted us to be using the non-contact voltage indicators. Now, again, the earth for one of these meters, it cannot go through the back of the box. It has to go out through the bottom of the box where the pipe is, because the integrity of this box cannot be broken. Now, the meter box itself can be in the cavity, it can be in the floor, it can be the one stuck on the outside of the wall. It can be in any meter box, but if it is in a meter box in the cavity, it will need to be vented, the box, because there's no way we can have, if anything goes wrong with this Anaconda, we've got 2 bar or up to 2 bar going into this box, and we don't want it going in the cavity and obviously explosions occurring. So on our visual inspection, if it has got earth bonding and the earth bonding goes anywhere else but out through the bottom, we can at risk this appliance because the integrity of the box has been damaged. So the earth bonding, remember, 10mm cross-sectional area going to the consumer unit or an earth point, and it's got to be within 600 of the meter or before the first branch. But if the meter box is outside, you can still put the earth bonding inside the property as close as practicable to the meter where it enters, if you can see the pipe and the earth bonding. If you can't see the pipe and the earth bonding, it has to go in the box. Anyway, that's earth bonding. So other things on the visual inspection, the box itself, if the box is damaged or broken, it's at risk. So these are the things we've got to be looking out for. So let's have a closer look at these labels. Now, the first label we've got here, which is the medium pressure warning, do not remove the rear knockout, and that's telling you don't go through the back with the pipe. The next one we've got here, it says warning, medium pressure gas supply. This installation is supplied with gas at medium pressure up to 2 bar. The meter pressure regulator setting is 21 millibars. So that's another, and that label will be about here. There's also another label which I've got on the top of here, which gives the customer the information on how to reset the lever mechanism. And then the last one we've got here, which says medium pressure outlet pipework and vent must exit through the base of the box. So these stickers, well, they come with the regulator, sorry, and must be installed in the box. That's again on your visuals. If these stickers were missing, some of you are going to start screaming at me now, not to current standards. Okay, you would be notifying somebody that you won't be running a warning notice or putting any stickers down, but you would be telling the responsible person that it should have these warning labels and how to reset the actual regulator if anything happened. So the visual inspection on this meter is incredibly important. One, it can't be inside. Two, the vent pipe's got to go out of the box. Three, it's got to have these labels. The earth bonding's got to come out through the bottom. These are incredibly important things on the visual inspection we should be looking for. So first one, visual inspection, very, very important on medium pressure. Very important on any meter, because if it hasn't got an earth, we need to be protecting ourselves. Now, before we do anything else, let's have a look at this process, what we've got to follow when doing a tightness test on this medium pressure. So this is a procedure we're going to be carrying out when this meter inlet valve, the MIV, is not fitted to IGM G111P edition 3. So carry out a let-by test on the ECV as follows. So turn off the gas at the ECV and adjust the pressure to the installation between 7 and 10 millibars. Operate the UPSO or excess flow valve reset mechanism to balance the pressure either side of the regulator and then allow it to reshut. If when operated the UPSO or excessive flow valve, the release of the trapped pressure causes the pressure in the installation to rise above this 10 millibars, then readjust the pressure to between 7 and 10 millibars. Check for any permissible movement, that is a rise, on the gauge reading over the next 1 minute period. Let's have a look at the let-by test on the meter inlet valve if it was actually installed on the system. So allow any release mechanism on the regulator to return to its off position. Close the MIV to reduce the system pressure to between 7 and 10 millibars. Open the ECV for 1 minute, looking for more than a 0.25 millibar rise on the test equipment. More than this 0.25 millibar rise would indicate the MIV is passing. Following a successful completion of this let-by test, close the ECV and release any pressure from the system. Now let's have a look at the regulator let-by test if the MIV is not fitted. So allow the release mechanism on the regulator to return to its off position. Open the ECV for 1 minute, looking for more than this 0.25 millibar rise. Following a successful completion of the let-by test, close the ECV and release any pressure from the system and reseal. Open the ECV and then slowly rise the pressure in the installation between 18 and 19 millibars. Reset the UPSO mechanism. Turn off the gas supply. Allow 1 minute for the temperature stabilization. Check for any pressure drop over the next 2 minute period and that the pressure drop over this period doesn't exceed this permissible drop for the gas meter. Upon completion of the test, remove the pressure gauge and reseal the test point at the meter test nipple. Where connections to the gas supply, slowly turn on the gas supply, test the pressure test point, the ECV outlet connection, the regulator connections, and where appropriate, the MIV connections with leak detection fluid. If required at this stage, purge in accordance with the IGE UP1B and check for the appliances according to the Appendix 5 of the Gas Industry Unsafe Situations Procedure. Now, if it fails this tightness test, then you need to trace or repair the leaks, and if you can't trace and repair the leaks, then you need to make the installation safe. Record your results and then, where appropriate, inform any responsible persons. So that's the procedure. Let's have a go at doing it. Let's have a look at the rig I've got set up. So basically I've got a air pump pressurising this expansion vessel. Well, it's not an expansion vessel now, from an old Worcester high flow. I've got my ECV here connected to this made up anaconda coming to the regulator. So the pressure I've got in here is 1.2 bar. Remember, this could be more than 75 millibar up to 2 bar. So I've got 1.2 bar in this vessel coming up to the ECV. Now I'm going to be using a digital manometer rather than a U gauge, and if you are going to do tests on this with a U gauge, be ready for your water to keep getting blown out. When you operate the reset valve, sometimes it blows your water out your U gauge, and we don't want that happening. It depends on your pressure of what you've got in your system. Now what I'm going to do is first I've removed the test nipple from out of this E6 meter. Now there's no pipework connected to this. It's just basically there's a blank inside here to stop any gas coming out through here. So really we should be using the purge point, a cooker, to get rid of any excess pressure. So it's a kind of a bit of a pain when you've got no pipework on here, but I'm giving you the worst case scenario. So we're just basically testing this meter and the regulator, the anaconda, and there's no pipework to test on here. So first thing I'm going to do is I'm going to open the mechanism and make sure I've got rid of any excess air or gas, in this case it's air, out through the test point here. So I'm starting at a 0 point, so I've got no air whatsoever in this system. Now the first test, as always, is to do a let-by test on the ECV. Now according to BS 6400 for this tightness test procedure for this particular regulator, it says we must get our let-by pressure between 7 and 10 millibars. Now years ago, when these first came out, we used to do the pressure test, the let-by test at 0, which I personally find a lot better and a lot easier than doing 7 to 10. But the regulations now say this is one of the tests we can do to prove let-by. It doesn't say it's the only test. It says one of the tests, 7 to 10. And what they've done is they've tried to make it a standard through LPG, natural gas, medium pressure, low pressure, that our let-by test on an ECV is between 7 and 10 millibars. Now then, I'm going to connect, I've opened that now and I've equalised the pressure on either side of the diaphragm. So I've got no air inside here and nothing into the meter. And if I connect my digital manometer on there, then it's reading 0 millibars. Now then, let-by test, what it says to do is open the valve or the reset handle, allow some gas in, and then drop the pressure down to 7 to 10 millibars. Now, what's wrong with leaving that ECV down here closed, opening the reset valve like that, and leaving it for a minute and seeing if it rises? And again, our permissible rise on this, because it's only to 1 decimal point, is 0.2 millibars. So this could actually rise 0.2 of a millibar and still be classed as 0. I've now got a reading on here of minus 3.6 millibars, holding open this lever valve. So basically it's created a bit of a vacuum rather than a pressure. Now, if I hold this open now for 1 minute and it doesn't rise, doesn't put any gas in, that means my ECV is not passing. This 7 to 10 millibar bit, it's a bit of a pain. So you can choose. Put down in the comments down below, what would you rather do? Now open the gas valve and allow 7 to 10 millibars into here, or leave it at 0. Remember, British Standard BS 6400 says one of the tests is 7 to 10 millibars. So once we've done for a minute and we've got no rise, then we know the ECV is not passing. So, take my hand off now, and we've gone to 0.7 millibars. Okay, but we've now got a pressure in here of 0.7. Remember, it's because of equalising the pressures, and I've got no pipework. It's just the gas meter. Now, the next test is to see whether the reset lever is passing. Now, again, in the new BS 6400, it says to open the ECV again to 7 to 10 millibars and see whether it's passing. But why not do it? Why not? If I open this now, so I've opened the ECV, and you could hear the air from the vessel then come into the bottom of the regulator. And if I get a pressure increase of more than 0.2 millibars after a minute, then that's saying that lever's passing. But what it says to do is open the lever, allow the air in, well, the gas in, to 7 to 10, then take your finger off the valve, off the reset valve, let it stabilise, drop it down to 7 to 10, and leave the ECV valve open to see whether it's passing or not. Whereas I've just opened that now, allowed the 1.2 bar into the system up to here, up to the regulator, and I've got a reading of 0.9 millibars now. So if I leave it for a minute now and see whether that's passing, you've got 1.2 bar there, you're going to get it. If that's passing, you're going to get it coming in and reading here. So I'm flickering now between 1 millibar and 0.9 of a millibar, but remember, there's no pipework connected on here, it's just the meter. And again, if I leave that for a minute, that's a let by done on my ECV and a let by done on my regulator. Now if I close the ECV off, I've still got 1.2 bar in there, and I operate the mechanism. Listen for the click. You could hear now it click, and I've now got 27.1 millibars coming into the meter. It's now 26.8 millibars. It's not allowed to go over 27.5 when you activate that. So your water shouldn't fly out at the top. But again, it all depends on, if I had 2 bar coming in here, I opened it up, sometimes it does initially fly out. I've got to now do my tightness test. So I've got my ECV, I need to keep that lever open to reset it, and now I can drop the pressure down to do my tightness test as normal. But the pressures we do the tightness test with this regulator are not between 20 and 21, it's between 18 and 19. So we have our pressure in the system between 18 and 19 for 1 minute for temperature stabilisation as normal, and then your 2-minute test, and then your permissible drops are the same. So once we've reset the lever, we've got equal gas pressures because we've got the ECV shut off. So we've got equal gas pressures in the system. We drop it down to our 18 to 19 millibars. We do 1 minute temperature stabilisation, 2-minute test. So that's pretty much the standard test. Now, this MIV, meter installation valve, we've also got to test that for let by test if it's fitted. And it says if it is fitted, you do the standard tightness test procedure using that. But have you tested whether all this is? Because if you're closing that valve, then are you testing that, whether that's dropping? That's the bit I don't get. It's when it says go back to a standard tightness test procedure. To have a bit of a recap, we could have up to 3 let by tests. We could have the ECV, the regulator, and the MIV. We've got to test those for let by. It says if the MIV is in the unsafe, the iGen G11 unsafe situations procedure, if that is passing, it says deem it at risk and get in touch with the ESP. And this is where attaching a warning label and the notice and stuff like that doesn't really gonna, sort the fault out. So it says don't do that. Just issue your warning notice, don't put your sticker on, and notify the ESP and leave it isolated. Because remember, it's their responsibility. That's if that's passing. Obviously, if the ECV was passing, you do your normal reporting it to Cadent. So there were the first tests. We then we operated the lever valve, and we tested to see whether the ECV was passing. We then closed the regulator, we then opened the ECV, we allowed the gas into the system. So in British Standard 6400, it says operate this to between 7 and 10 millibars with that valve open and see whether it passes. And then remember, the temperature stabilisation and the tightness test procedure for this regulator was not 20 to 21 millibars, it's 18 to 19 millibars. Still 1 minute temperature stabilisation, 2-minute test, and you still follow the permissible drops for the E6 meter, 8 millibars, appliance connected, no smell of gas. In this situation, it'll be 0 because it's got no pipe work, no appliances. Slight difference again with working pressure with this. Maximum working pressure on this is 22 millibars plus or minus 2 millibars. So 20 to 24 millibars would be the working pressure for this regulator, unlike your low pressure 21 millibars plus or minus 2 millibars. So that's the differences in that. So we've got one more test to do now. I'm going to show you that, and it's a test to see whether this is passing. Because if this vent pipe is passing all the time continuously, that's ID. So let's have a look at this test for that. Now, to test that this isn't passing through here, passing through and out through here, the test it says to do is get a glass of water, get the pipe, so you could actually pull it out of the box itself and do the test in the box. So it says place about 5 ml of the tube into the glass, operate the valve, you should get bubbles coming out for the first few seconds, and then leave it for up to 15 seconds to see if it's continually passing. So I've got the ECV on, got my test nipple back in, I'm going to operate the green lever, we should get some bubbles first, which we did, and now we should get no bubbles coming out for up to 15 seconds. And that's proved the regulator, the vent pipe is working. It shows you the vent pipe's working anyway. And that's a test you should do to see if it's continually passing. And as you can see, it's not. It also says there's another test we can do on the relief valve, is to actually blow the relief valve off. So we could actually connect onto here and we can pressurize the system. And it says depending on the actual valve, this could be as little as 27 millibars up to 35, 37 millibars, depending on which valve it is. And then it will blow off the safety device. This is the rig I've got set up now for testing the relief valve. Now, according to the manufacturer for this type of valve, it says it should blow off before it gets to 37 millibars. Actually says between 27 and 37 millibars. So that's what we're looking for. Remember, we'd have a working pressure of 22 millibars plus or minus 2 millibars, so we would be around about 24, so 27 is a bit close, but anyway. So what I've done here is I've got my little air test kit to get me over the pressure. I've now got the tube going through into my glass of water so you can see it bubbling. I've got my digital manometer set up now, and the digital manometer is reading 0.1 millibar. So I'm going to use my little air pump now, and I'm going to blow it up and hopefully pressurize this system. I've taken my little disc out of the meter, so that's been taken out, otherwise it won't work. And let's see if it actually does blow off and what pressure it does blow off at. So I'm starting to gently pump. We're at 19, 17, 21, 20, ooh, 28 started. So it's blowing off now. And it started blowing off at about 28 millibars. So there, 31 millibars it's blowing off at. 33. And it's not allowing it going above the 37. It's trying to keep it lower than the 37 millibars. So we can see the relief valve is working and it's resealing, okay? Because I've got 25 millibars in here now, 23 millibars, and it's not blowing off. So that's how you would test whether the relief valve is blowing off or not. It's as simple as that. Now, if you've enjoyed this video, why don't you give us a thumbs up or leave a constructive comment down below. If you do the test differently, like I said earlier in the video, leave a comment down below and say how you do the test. Because remember, the British Standard says one of the tests. It doesn't say it has to be that test. Okay? And if you're not subscribed to our channel, get subscribing. And don't forget to hit that notification bell because we release videos every Wednesday. And as usual, guys, going to finish off by saying thanks for listening. Thanks for watching. Thanks for your time. Tune in next Wednesday for another video. Thanks guys.